Hey, hello all. My name is Ajit Chadaka. Welcome you all to the second session on TensorFlow. So, in this particular session, we would be continuing from where we had stopped in the last session. So, we would be exploring mathematical operations that can be done in TensorFlow and the concept of variable and few probability functions such as softmax functions, what we would be implementing in TensorFlow. So, let me share my screen right now. Okay. I hope my screen is visible. So we would be starting with TensorFlow mathematical operations such as addition. So in the beginning, what I would be doing is I would be importing the TensorFlow library which we require. So import TensorFlow as TF. Okay. So in the next line, we would be using this TF alias and we would be calling a method called as dot add. So basically to perform a addition operation, and I would be passing the value 5 and 2, and this should be assigned to a variable called as x. When I execute this, I won't be seeing the output 5 plus 2 is equal to 7, because in TensorFlow, basically, when you perform the operation, you just get an output as tensor object is being formed. You don't get any output. In order to get the output, basically, you need to create a session. So how do we create a session? I believe we have covered the concept in the last class. So session basically helps us to perform the operations. Basically, it provides resources in order to perform the operation. With tf.session as ACSS, output is equal to session.run. And inside the parenthesis, basically, you pass the variable where the operation is supposed to be done. So here we had assigned tf.add 5, 2 to a variable called as x, and we will be passing the same value here, and later we will be printing the output. When we execute this, basically you will be getting sum is equal to 7. So this is how we will be able to achieve. So in the similar way, let us take another example of creating the placeholder concept. So in the last session, we had covered placeholder. So placeholders basically used in order to pass the value during the runtime. So here I've taken two placeholders. One is A and B. So both have kept a placeholder which accepts only integer data type. And later I would be creating a session, and I would be feeding a value 7 and 3 basically. And here the operation A plus B happens. So basically A is accepting 7 because I've given integer data type, and B is accepting 3 because B I've defined already. It is supposed to take only integer data type, and after taking it's supposed to perform addition operation. So all this happens during the runtime. So when I execute this, basically okay. So basically, I'm able to get 10. So this is how the addition operation is being done. So let us see the next operation, mathematical operation, which can be done in TensorFlow. So I would be calling TF alias, and I would be calling a method called as subtraction, basically to subtract two numbers. So here I have given 10, 4, and I have passed it to a variable x. So when I execute it, similar to addition, we will be getting only TensorFlow object. So in order to perform the operation, you need to create a session with tf.session as a CSS. Output is equal to session.run. So when I execute this, basically I will be getting the output as 6. This is nothing but 10 minus 4. Okay. So the next mathematical operation we will be seeing is multiplication operation. So similarly, how I had done subtraction. So similar way, I would be calling the method called as multiply, and I would be passing the value 2, 5. So when I execute it, I will be getting the TensorFlow object. So in order to execute it, again, I have to create a session and pass it. So for each operation, you need to create a session and pass that particular operation. Okay. So this covers all the mathematical operations. How do we do it in TensorFlow? So the next topic, what you would be seeing is how do we convert the data type from one data type to another data type. So here I have taken one example of subtracting basically two numbers. So two numbers in the sense, here I have given constant as 2 and I have given another constant as 1. So 2 minus 1 operation is supposed to be done. So when I execute it, basically I would be getting an error. So let us see what does error means. So it's a type error. Basically, the input y of sub of output has type integer that does not match the type float of argument x. So basically what it is communicating or trying to tell us. So basically tf.constant 2.0 is basically a floating data type. tf.constant1 is basically a integer data type. So these two data types are totally different. So that is the reason we are getting the error. So how do we convert or typecast it from one data type to another data type? So let us see that. So as you can see in the example in line in cell number 12, so TF or subtract. So inside that I've called a method called as cast. So basically it converts this TF dot constant 2.0 into an integer. So this is already an integer, you don't have to convert it. But this particular floating data type, you have to convert it to integer. And when you execute it basically and pass this particular operation in a session, we would be getting an output as 1. So this is how we perform the typecasting operation. So let us see another example. Okay. So here I have imported the TensorFlow as TF. I have defined two constants, tf.constant 10 and tf.constant 2, and assigned to a variable x and y. Okay. In the next step, basically, I'm basically doing a method within a method operation. So where tf division operation happens first and later the subtraction operation. So division is x comma y, 10 by 2, 5. So 5 comma 1 subtraction is nothing but 4. So the output what we are supposed to get is 4. So again, we will be opening the session with tf.session SCSS and we will be running this particular operation. So when you execute this, basically, we will be getting an output as 4. Okay. So this is how we perform basically subtraction. First, a division operation happens and later the subtraction operation, and pass the complete operation in the session to execute. Okay. So coming to the next topic, basically, so in a TensorFlow linear function, so basically the equation goes y equal to mx plus c. So here m is nothing but w weight parameter and c is nothing but bias parameter. Okay. So the main goal of training any neural network is to modify or keep changing these weights and biases to basically get a best model, basically to predict the labels. So that is the main intention of any neural network. Basically, in order to get the best model, basically you have to fine tune this weights and biases. Okay, so you'll need the TensorFlow. Basically, you'll need a tensor that can be modified. Okay, so till now we have seen tensors such as TF got constant, TF the placeholder. So all these cannot be modified since those tensors can't be modified. Okay, this is where the concept called as TF dot variable comes. Okay, where you can change it. Okay, so that is the reason we are going to use TF dot variable where it is where the weights and biases would be defined. Okay, so that would help the neural network to modify the weights and biases. Okay, so here we would be defining a variable tf dot variable and we would be passing a value of 5. Okay, and when you execute it similar to constant and placeholder, we would be getting a tensor object. Okay, one thing in variable is in order to execute, we have to create a session. That is fine, that is similar to constant and placeholder, but along with this we need to create something called as global variable initializer. So we need to create that particular variable, and again during runtime or during the session has been opened, we need to pass this particular variable along with the operation. So this is one particular uh, compulsory element which is supposed to be implemented during the session. So when I execute it, basically you will be able to see 5. So I've defined a variable 5 into x and I'm able to run. So this is one particular syntax or one particular way of creating a variable. Okay. So let me take another example. So here what I've taken is basically tf dot truncated underscore normal. So basically in order to perform a normal distribution. So n features is equal to 120 and label is equal to 5. So I will be creating inside tf dot variable tf truncate normal and n features comma n labels, which is 120 comma 5, which means 120 rows and 5 columns. So that is what is the meaning, and this will be assigned to weights. Okay, when I execute it, I would be getting a tensor object. Okay, so how do we perform this operation? In the similar way, I would be creating global variable initializer and assigning it to a variable called init. Okay, and later I would be creating a session and running the operation what I want. When I execute it, basically, I would be able to see the output. Basically, it has a normal distribution output of 120 rows and 5 columns, which has been defined. So, similarly, going to the next topic called as TF dot zeros. So in NumPy, we had similarly NP dot zeros where zero element was being created in matrix. Okay. So in the similar way, let us see how do we create zeros in TensorFlow. So here I have given n label as 5. And basically the bias of what I've given is tf dot variable. Inside variable, I have defined tf dot zeros, and labels have defined as 5. Basically, when executed, basically I would be getting a tensor object. So in the next line, basically I would be executing these operations. When I execute it, basically I would be getting 5 zeros. So this is how we define the zeros in TensorFlow. So just to give a recap of how do we define it in NumPy. So I've imported this particular package called as import NumPy as NP. So when I give np.zeros 5 comma 4, basically you get 5 rows, 4 columns. So this is how we define in NumPy operations. Okay. So to just to give you a recap, we have started with mathematical operations such as addition, subtraction, and multiplication. And we have seen how do we define variables and how do we define normal truncated variables. So how do we add zeros? So what is the use of having tf dot variables when we have tf dot constant and placeholder? So basically, tf variable helps us to assign or modify the weight and bias parameter that will help us to get a very good neural network or a good accurate model. So that is the main intention of tf dot variable. Okay. So coming to the last topic. So basically TensorFlow softmax. So basically a softmax is one of the probability distribution function. Basically, it basically squashes its input. So into a confined 0 to 1. So basically it normalizes. So the other name for software function is also called as logit score. So basically whatever may be the input, so when it passes to the softmax, the software function reduces it and the output would be somewhere between 0 and 1. Okay. So basically the formula for softmax is e power y, okay, divided by sigma of e power y. So that is the main formula of softmax function. Okay, so here in this particular diagram, as you can see, 1.2 is fed to softmax and the output is 0.46. So zero point 0.9 is fed to softmax, the output is 0.34. 0.4 is fed to softmax and output is 0.20. So how this is calculated in the sense internally, there's a calculation that is happening. So as I said you, the formula is e power y divided by sigma of e power y, which means e power y is nothing but 1.2. E power 1.2 divided by summation of e power 1.2 plus e power 1.9 plus e power 0.4. So when we do this division operation, we get an output called as 0.46. In a similar way, 0.34, 0.20 is being calculated. So you don't have to do it any manually. So TensorFlow would be helping us to perform all these operations internally. So let us see how do we do that. So here basically I've taken the TensorFlow input variables. So 2.0, 1.0, 0.02. So basically when I execute it, I would be getting a TensorFlow object. Okay. So let us take an example of few TensorFlow operations. How do we do? Okay. So first step is I'm importing the TensorFlow as TF, and I would be creating a function called as run2. So inside run2, I've given a logit data. Basically, I input a softmax input to the softmax function. Okay, and later I'm creating a placeholder that it can take a floating point number. Okay, and later as per the softmax function tf dot nn dot softmax and logits, basically passing this particular placeholder into logits, and later in order to perform these operations I'll be creating a session with tf dot session, basically session dot run, and I need this particular output where it is supposed to perform the operation, and I'm basically feeding the value. Basically, it's logits and logit data is in the form of key value pair. So logit data is holding these values, okay, and logits is holding tf dot float. So in the next step, what does it do? Basically, tf.float has been passed to softmax. Okay, so logits has been assigned here, and this would be passed into the softmax. In return, we would be getting the output. So basically, when you execute it, basically you would be getting an output, the output of the softmax function, which is nothing but 0.33, 0.33, So this is the output of softmax function. As you can see in the input is so high, whereas the output is confined between 0 and 1. So this is how we calculate the softmax function. So just to give you a recap, in this particular session, as discussed, we have completed how do we perform mathematical operations, how do we define the variables, and how do we do the typecasting from one data type to another data type, and the softmax function. Okay. So hope you like this particular video. Thank you all for joining.